I will give you the final presentation of the evening here. And if I could have the lights turned off, please, because I'll be using a PowerPoint presentation here to illustrate what I'm talking to you about. I have a laser pointer here too. I'm hoping that the people in the back of the room will be able to read most of the text. There might be some where the text is a bit small, and I'll mention what's there. Sometimes it's just not all that terribly important. Just to introduce myself, I am, there we go. I am Keith Benn. I am a professional geoscientist practicing in Ontario, originally from Wallaceburg, presently residing in Port Lambton. I have several degrees, culminating in my doctorate, and I was a tenured assistant and associate professor at the University of Ottawa for 17 and a half years. And in 2008, I voluntarily chose to leave the university and went back to the minerals industry, and I've been working in the minerals industry ever since, now as an independent consultant. Most relevant to this evening is that from 2019 to 2021, through 2021, I served as a member of the expert panel that advised the all-hazard investigation of well water in Chatham-Kent that was inspired by the numerous complaints following the construction of 3 industrial wind complexes from people whose well water had apparently been impacted by the construction and operation of those wind turbines. I'm not sure if you can read it this far down here, but basically what I'm saying here is I just want to make clear what the role of the expert panel was, of which I was a member. 2 roles. First, to provide technical advice upon request to the Ministry of Health. We did not plan the whole investigation, and we certainly did not manage it. That was not our responsibility. That was the responsibility of the Ministry of Health. And our other task was to look at all the data that were collected and, in the end, write a final report, which we did, and we submitted in December of 2021 to the Minister of Health. A brief outline here of what I'm going to talk about. First, I'll give you an overview of the all-hazard investigation. I'll provide a bit of context of the geological environment and the composition of the aquifer, which is where the problem arises. And we'll look at the scope of the investigation as it was defined by the Ministry of Health. This is very important. And a brief summary of the results. Some of the results are very useful, as you'll see. Sadly, though, big note here, the Ministry of Health failed to properly complete the investigation. As 1 or 2 people have already mentioned this evening, they did not sample any of the sediment that's in the water and analyze it. They only analyzed the water itself. And I'll show you the results. Then I'll take a few moments to talk a little bit about the sales pitch that you'll be facing if it turns out that Capstone proceeds with this project. Please understand that anytime that their people come and talk to you, they have one task. That is to make this project happen. They're salespeople. So you have to be prepared to think with use your critical analysis a little bit when you listen to what it is that they say to you. And I'm going to focus myself on this issue of model predictions of what will not happen if they build the industrial wind turbine complex. I believe Denise already mentioned this evening, and perhaps some other people as well. I'll give you some insight to what that means exactly when they model something. And I'll probably take a moment to mention another potential risk or hazard that you might want to consider, and that is methane gas and hydrogen sulfide gas, which is present in some people's water already, but it could get worse. It could get worse if your aquifer is disturbed by industrial wind turbines. So I don't need to spend too much time on this because you've heard a lot about it this evening already. The motivation for the all-hazard investigation, the complaints about turbidity, the cloudiness of the water, due to sediment load, okay? Particles, very fine particles in the water. During the provincial election of 2018, when Mr. Ford was the new leader of the PC party, he promised that if he formed a government, if his party formed a government, that they would carry out an investigation. As Christine pointed out, it was originally promised to be a health hazard investigation. They switched that, they did a switcheroo on that, but they did carry out an all hazard investigation. And I was invited to be a member of the expert panel. Now, context. Geological context here. You've seen this map already. This is the North Camp 1. Oh, the all-hazard investigation, by the way, focused only on the North Camp 1 complex, as Christine mentioned, not the other two that are there. This is the North Camp 1. I might be standing in front of this here. Let me move out of the way. Sorry, I'm going to be blocking this a bit. Maybe if I go over here, that would be better. There we go. That's the North Camp 1 complex. What you see in green here is what geologists like myself, call subcrop. In other words, the rock is not cropping out its surface except in a few select areas, but it's in the shallow subsurface. Okay, it's the bedrock. And that is the Kettle Point Formation, as it's called. It's a black shale. Now, the reason for the concern, as we'll see in another image here in just a moment, is that a lot of that black shale has been ground up and transported by glaciers during the last glacial period here, which was around 14 to 12,000 years ago, approximately. And when the glaciers recede, this is typical of glaciers, as they grow and expand across bedrock, they rip up fragments of various sizes that get caught up in the ice, and then when the ice melts later, the stuff is sedimented onto the bedrock there as the glaciers recede. And that's what the aquifer is composed of. There's a lot of black shale as well as other types of fragments in it. Now, the first problem is the aesthetics, as it's technically referred to. Basically, that means the water quality. You've seen images, I just showed one, and other people here have shown them this evening. This is not water you want to bathe in. This is not water you want to drink. This is not water you want to boil your pasta in and then eat it. So the water quality is very poor for many of the wells. And as we'll see, that's almost certainly due to the industrial wind turbines. But even more worrisome is this question of the Kettle Point Formation being recognized by geologists. It is classified as a metals-rich black shale. As someone else mentioned here, there's one publication, well, this was originally based on data in a master's thesis at the University of Waterloo back in 1986. The Geological Survey of Canada has recognized that to be true. So we have a lot of this black shale in the water as well, and that's really the critical issue here. So I want everybody just to, it's been said already, but for the next few slides I'm going to show, it's important to really keep that at the front of your mind. The whole motivation for this all-hazard investigation was that fine-grained sediment in the water, okay? They wanted to collect it, analyze it, and see if there was any hazard associated with it. Now, some other people have talked about this a bit. I wanted to show this table. This is from one sample of sediment. This is prior to the all-hazard investigation, by the way. But this explains why you get so much of that sediment showing up, coming out of your taps. Even if you have a really good filtration, domestic water supply type filtration system in your home. This sample, from this sample, they took some sediment. Angela talked about this. And they analyzed the grain sizes. In the columns here, you have different grain sizes. This is the units are microns. A micron, of course, is 1/1000th of a millimeter. So this is less than 1 micron, 1 to 2, 2 to 5, etc. And don't worry too much about how these different fragments are classified here. Some of them they call black shale. Some of this iron rich could have been very well been black shale as well, and the unclassified as well. But if you can see the bottom row that I highlighted with a red box, that's the total number of fragments in this particular sample. And as you can see, the largest numbers were for fragments less than 2 microns in size. These are invisible to the unaided eye. They're very tiny. They're impossible to filter out with even a really high-quality domestic water supply filtration system. So once you get this kind of disturbance in your aquifer, if there is this kind of sediment in there, this kind of black shale sediment, you're not going to be able to filter it out. You just won't. And geologists, by the way, call this, in this grain size, we call this grain size, it's sizes of the particles. This is silt. This is all referred to as silt, and this is clay, based on the size of the fragments. Now, this is the final bit of context here, I think. There might be one more slide for context. But this is what geologists call a cross-section. It's a vertical section through the upper part of the earth here. The geologists refer to everything that's unconsolidated sediment sitting on top of bedrock as overburden. So any aquifer that's used for wells that's above the bedrock in this overburden, you'll see it referred to as an overburden well, overburden aquifer. And here we have the Kettle Point bedrock. It's something like 16 meters, plus or minus a bit, depending where you are, below the surface. And the aquifer is a contact or interface aquifer that sits right on top of the Kettle Point black shale, but within the overburden. Now, you're not going to be able to read all the fine little text here, but I'll point out the important stuff. This is the aquifer, and the aquifer is known to be composed in large part of gravel and sand. But there's also quite a lot of black shale. Now, what the people who put this schematic cross-section together, which was Golder Associates, we're going to see this again in a few minutes, but with more information added to it. You know, they put a little box over here and they said, oh yes, and by the way, this was done prior to the construction of the North Kent 1 wind complex, by the way. This was part of a study of whether there would be a hazard, interference with water wells or not. And so they put a little box over to the side here and they say, oh, there's some black shale here and there, but it's just inside this little box. Don't worry about the rest of the aquifer. It's all nice and clean and gravel and sand. There won't be any problem. We'll see that that's not really the case. Okay? So this is what you're tapping into with the wells in North Kent, into that contact aquifer. Now, here, let's get into the investigation. The scope of the investigation is officially defined by the Ministry of Health. This is in the request for bids that was sent out to any potential contractors who might want to do the sampling and the testing. It officially says objectives are, 1, to collect and test water and, underlined in red, sediment samples from private wells in the area. And the vendor would or will complete well water and sediment sampling and testing to inform the all hazard investigation about any potential hazards. Okay? Sediment, over and over again. This was the main it was really the only motivating factor to launch this investigation to begin with. Okay? And it's officially there. That was something that was a main objective. You're not going to be able to read all the text on this. You don't really need to. I wanted to include it because it has the logo on it here, on Ontario Ministry of Health. This is the news release that went out when the all hazard investigations was finished after about 2.5 years of work. Okay? And they say, don't worry, we didn't find any widespread health risks. There were a few. We'll discuss, the ministry will discuss with the few people who had some lead and arsenic in their water. But all in all, there's nothing to see here. Move along. We're done. Well, in the black box here, I added, not even a single sample of sediment was collected. Therefore, the sediment remains entirely untested at that time for potential toxicity. What this means is that the Ministry of Health failed. They did not complete this all-hazard investigation properly. One of the main objectives was to sample and test the sediment. They didn't get any of it. Now, I'm not going to get into a discussion right now because I don't have time. And the question and answer, if you wish, I could give you some insights on why I think that happened. But and it's not necessarily, malevolence. It could just be incompetence. But it didn't happen. Okay. Uh-oh. What's happening here? There we go. Now, here is one set of results that we did get out of the all-hazard investigation that's useful. Okay? These are called the aesthetic parameters, or measures of, ways to judge water quality. And what we were able to do as the expert panel was to take the different values that were determined for the water, and I've just taken out 3 of multiple, what are referred to as aesthetic parameters. Iron content, total suspended solids, which means sediment, just translated as sediment, and turbidity, which is the cloudiness of the water. And because there was a baseline study done at North Kent 1 prior to construction of the wind turbines, we could compare the data that were collected during the all-hazard investigation, when the wind turbines were there and operating, with the data that came from before the wind turbine construction, before and after. And what did we find? Lo and behold, iron content was up 66%. These are means, calculated averages for the 61 samples, okay? Iron content was up 66%. Sediment content up 51%, and turbidity up 35%, okay? So, something happened to impact the quality of the water coming out of people's wells after the construction of the wind turbines. I wonder what it might have been. I wonder. We have a second comparison that we were able to do. That was with a reference group. So this is not before and after, this is a spatial comparison. The reference group was 9 samples collected from wells, tapping into the same aquifer in North Kent, Dover, but outside of the footprint of any industrial wind turbines. Okay? So sampled at the same time for the same study. Spatial comparison. And it turns out that the water from inside the wind turbine complex is 83% richer in iron, 160% more loaded with sediment, and the turbidity is 300% higher. So whatever affected the water inside the wind turbine complex didn't affect the water outside of the wind turbine complex. Now you can hand this problem to any grade 5 student, I think, and say, do a 2 + 2 and tell us what caused the, impacted the water. And the grade 5 student would say, well, it must have been the wind turbines. And in fact, I think that this is proof positive that it's the wind turbines that affected the water. There are still people who will tell you it's not the case, but follow the science, people. This is the all-hazard investigation funded and managed by the Ministry of Health that gathered these data, and that's what it tells us. As far as I'm concerned, anybody who doesn't want to believe that the wind turbines caused this problem, the burden of proof is on them to prove that it didn't, not on us to prove that it did. This already, in my opinion, proves that they did. Now, as a result, part of our task writing up the final report was to provide recommendations for further work that needed to be done. And we submitted 10 recommendations, but I'm only going to speak about 2 here. The top one, the top bullet point, and the bottom one. One follows from the other. This recommendation was, obviously, you guys didn't capture any of the solid particles, any of the sediment. That needs to be done. We need to go sample that, or somebody does, and then test it and find out and complete the work that was supposed to already be completed, and find out if there are metals in that sediment. because we know that Cattle Point is, black shale is metals rich. And then if you find concentrations of metals in that sediment, then something called bioaccessibility testing needs to be done. We put that as an official recommendation in the official report that we submitted to the ministry. Bioaccessibility, I'm going to translate this for the context of this study. This is an official definition, but to translate that into the context of this study, bioaccessibility testing would test the quantity of the metals that were found or that are contained in or attached to the sediment in the gastrointestinal tract. In other words, if you consume that, do the juices in your stomach and your intestines release enough of that or leach out enough of that or any of that metal such that it could enter into your bloodstream and eventually into the tissues in your body? Because of course, if you have heavy metals collecting in the tissues in your body, that's not a good thing. And okay, so that report was submitted in December of 2021, and late in 2022, still not a whisper from the Ministry of Health as to whether they were going to follow up on those recommendations. So a group got together, Wallaceburg Area Wind Concerns helped us out. 9 well owners contributed money, and there was a GoFundMe program that raised some more money from very generous donors. And as I think it was Christine mentioned, we had a hydrogeologist come and properly sample these 9 wells, and with proper chain of custody, ship it off to the lab in Michigan to have the sediment analyzed or separated from the water and analyzed for metals using standard ICP-MS techniques. This is very standard stuff. Okay? And lo and behold, now I don't know if you can read this very well. On the bottom here of this diagram, you have a list of different metals that were found. Arsenic is here. Barium, cadmium, chromium, cobalt, lead, molybdenum, nickel, and mercury in 2 wells. Okay? The units are micrograms per kilogram. Don't worry about that too much. But I'll point out that the Y scale, the Y-axis here, is exponential. So every tick mark is 10 times the value of the previous one. So 10 micrograms, 100, 1,000, 10,000, 100,000, a million. Now let's focus on arsenic. That's kind of a scary idea that there would be arsenic in the sediment in your water. 8 of the 9 wells have significant concentrations of arsenic. Lead, 9 of 9 wells has significant concentrations of lead, up some of them well beyond 100,000, 200, 300,000 micrograms. And mercury over here, and then also all of these other metals. So, 2.5 years of work, the Ministry of Health failed to collect a single sample of this sediment and analyze it. Local people get together, raise a little bit of money, and boom, a few weeks later, here are the results. Done. So that's step 1 of those 2 recommendations that I read off to you a few moments ago. We now have proven that there is heavy metal concentrations, in this case, in every one of the 9 wells that were sampled. Okay? So the next bit of work that needs to be done, undoubtedly first, would be to sample some more wells, but then to do the famous bioaccessibility work to find out if that hazard, there's a hazard in that, that metal represents a hazard. Now we need to know the risk. In other words, how much damage is that going to do to you if you consume it? So now I'm going to do a little summary here of where we are. The saga continues, as has been mentioned here this evening, and this goes beyond the end of that bar diagram that I just showed you. But we'll start back here at the beginning of the all-hazard investigation in 2019. That's about 9 years after the first wells were impacted, when those first 2 industrial wind turbines were constructed. All-hazard investigation was never properly completed. Well. Expert panel called for studies of the sediment. Complete silence from the Ministry of Health. Late 2022 and in Q1 2023, private citizens had the sediments sampled and analyzed, and lo and behold, there are the heavy metals that people for years have been worried were present in the sediments. As Councillor Jubenville mentioned a few moments ago, on May 29, 2023, Council voted unanimously in favor of her motion to reach out to the Ministry of Health to ask them, once again, please follow the expert panel's advice and carry out the work that needs to be carried out. And as Councillor Jubenville mentioned, complete silence from the Ministry of Health. Nada, nothing, zero, zip. 2024, we circulated a petition that's also here for, as I mentioned previously, that's here for your signatures this evening if you care to sign it. The petition asks the Legislative Assembly of Ontario to instruct the Ministry of Health to follow the recommendations of the expert panel, I'm summarizing here, and do some more testing of these sediments and bioaccessibility studies. We wanted this to be read on the floor of the Legislative Assembly such that it would go into the Hansard officially, which normally triggers a response from the Legislative Assembly as to whether they are going to satisfy our requests. And there were over 1,400 signatures. The local MPP, his office was contacted because Wallsburg Area Wind Concerns wanted to hand over this petition to the local MPP for Lambton-Kent Middlesex directly and request of him to read it on the floor of the Assembly. He never responded. I think his office responded that, oh, you can just drop it off at our office. We'll get the petition to him and he'll do something with it. Maybe he'll give it to the clerk of the House or something, which would have been a perfect opportunity. That would have been a final and complete burial of the whole thing, of course, because it never would have been read and into the Hansard. So, fortunately, another MPP very graciously and generously, in response to our request, MPP Bobby Ann Brady from Haldeman, Norfolk, she's an independent, presented the petition on the floor on June the 2nd, 2025. So now, that's where we are now. We wait for a response from the Legislative Assembly